So hello and welcome friends to our channel Intromech, and here we discuss about basic mechanical engineering concepts. So in our previous session we have seen a new platform called as virtual labs. This platform is created by well-known IITs and NITs, and it is very useful platform for the students because here we can get the simulations, the animations of the experiments which we conduct into the labs. So it gives the same experiments, and along with that it gives a tool with which we can play around and we can find out lot of different parameters how they affect the experiment. So you can learn a lot from this. So it is a very good platform. So without wasting time, let's get started. So today we will be watching the subject called mechanical vibration. So you have to go into the virtual labs, and this will the home page of virtual labs. Here you could see the home page and the broad areas of virtual labs. You can see all the subjects like electronics, mechanical engineering, right? When we go into the mechanical engineering, you could see a lot of different topics here, and that are developed by different IITs and NITs. So today we will be going to machine dynamics and mechanical vibration lab. So just click on it. As soon as you click on it, you will go on to this page. Here you could see mechanical engineering and the vibration lab. Introduction you can read, then there are objectives. What is objective? Then there is a list of experiments. So here you could see different kind of experiments like pre vibration of cantilever beam, then post vibrations, big excitations, and a lot of other things are mentioned over here. So let's see one experiment. So let's take a look of, say, free vibration of cantilever beam. So here now you could see the aim, then you can read some theory about it, what are free vibrations, how it are, how it is calculated, and all those stuff. Then you can read the procedure. They are given the step-by-step procedure, right? And then the most interesting part here, uh, we have also a self evaluation. That means you can read and then you can give the answers or here to check whether you have understood the concepts or not. And then the most important and exciting part is the simulation. So here it is the window. You can go into the experiment, and here you can see the single degree of freedom system, right? The variables on the right hand side, you can see the material, steel, aluminum, bronze. You can change. Then the sections of the beam, they have given like I section, T section, C sections, L section. So you can experiment with lot of sections. Now here you could see if I change the section, it is getting changed. So it's very good platform. Now we have taken circular section, right? Then we have length, then the damping ratio and the end mass. These also are the variables, and we can change them to check how it is affecting the outputs, right? So here uh, is the animation. You can click on the play and you will get the animation and the graph also, right? And the output values. So let's check out with some examples. Now here we have taken the steel with the circular section, and we can have the values over here. Now let's change something. We have changed now the length, we have changed the damping ratio, right? We have increased the damping ratio, we have increased the mass. Now let's see how it is affecting, right? So you could see here the animation. Just go back and you can see the values have changed, right? And here you can get the animation. Now let's see, we have played here, right? Now the damping ratio we have increased, so the vibrations you could see they are getting damped. So let's change the section. Now here you could see some more deflections over here. We have kept the mass same. Now let's reduce the damping ratio to 0. That means there is no resistance. So here you could observe that the beam is continuously vibrating because it has no damping, right? And now let's take a damping of 0.9, which is almost equal to 1. So here you could see that the beam is directly coming to the rest because there is a huge damping, right? So this is how like you can play around with this simulation. You can check out how the parameters are affecting the output. You can change length, material, and many different things. Now let's check out one another example like basic type excitation. So we are giving the excitation to the base, and let's see what we have into the simulation. Now here you could see we have the harmonic excitation to the base, then there is a damping, and we have output amplitude, and we have input uh, amplitude. That means we are giving the excitation to the base, and that's why the output is vibrating. So how you can relate to this? There is some kind of machine, it is grounded, right? And if there is a let's say some explosion, so the vibrations will be given, will be there onto the base, and that will get transmitted to the system. So we have to check that whether the system will sustain those vibrations or not, right? So this is the example. Now here we have variables like stiffness, mass, then the damping ratio, excitation magnitude, then the excitation frequency. So all these things we have. Now we have increased the stiffness. You could see how the graph is changing. We are increasing the mass. You could see the vibrations now uh, have increased. Then we have a damping ratio which is very less. Right now let's check. We have increased the damping ratio. Now here you could see the changes into the output amplitude, right? Uh, then we have the excitation magnitude, the damping ratio. If you could see, if we have reduced the damping, you could see the amplitudes, right? So if there is no damping, what will happen? The system will vibrate with a huge amplitude, and there can be the damage, right? Then the frequency, if the frequency of vibration is too high, you could see the output, right? So the system is vibrating at very high frequency. So you can read the graph, and this is how you can play around. And I think this is a great platform you are getting. You don't have to go anywhere, and you can just uh, go onto this site, which is completely free. You don't have to pay anything, and you are getting a lot of things to learn here, right? So then we have a graph section also. So when you give some inputs, it is generating some graph over here, and if you change some value, then again you can create the graph with these different values over here. So you can see now the second graph has been created, so you can compare over here, and this is another advantage you are getting, right? So this is how you can utilize this platform, and I think this is great because you are getting a visual uh, output, which is always a great use, right? So this is how you can utilize this platform, and we have seen this mechanical machine dynamics and mechanical vibration lab today. So thank you for your patient listening, and if you have any doubts, please do write into the comment section. Until then, stay home, stay happy. Thank you.